Good morning, students. Now we are going discussing about triangles and quadrilaterals. Okay, so we know about very clearly triangles and quadrilaterals. So the ratio of first one is in this one first concept. The ratio of the sides of a triangle formed by L1 is equal to 0, L2 is equal to 0, L3 is equal to 0. Here L1, L2, L3 are nothing but you take any line equations a1x plus b1y plus c1 is equal to 0, a2x plus b2y plus c2 is equal to 0, a3x plus b3y plus c3 is equal to 0. So if any triangle formed by these three lines a1x plus b, let us consider that means okay, this is one line L1 is equal to 0, this is one more line L2 is equal to 0, this is third line L3 is equal to 0. If this triangle formed by these three lines then ratio of the sides of a triangle, ratio of the sides means lengths. So first side length is to second side length is to third side length is given by first side is formed by a1x plus b1y plus c1. So here coefficient of x and coefficient of y we have to use, that is the root over a1 square plus b1 square into modulus of determinant. Determinant means 2 by 2 determinant, just to cross multiply to expand 2 by 2 determinant. So this is for determinant, this is for modulus, because whenever you have negative, so make it positive, you have to keep modulus. This is for determinant. Determinant means so a2 b3 minus a3 b2. So just cross multiplication, 2 by 2 determinant is nothing but okay. This is a2 b2 is the second line coefficients of x comma y. A3 b3 is nothing but third line coefficients of x comma y. Okay, so here a1 square plus b1 square under root modulus of determinant of a2 b2 a3 b3 is to same for second line a root over a2 square plus b2 square into modulus of determinant of a3 b3 a1 b1. So third line first line. So for second line you have to use third line coefficients and first line coefficients in the determinant is to root over a3 square plus b3 square into modulus of determinant of a1 b1 a2 b2. Okay, so very easily we can remember if you use this concept for first line root over a1 square plus b1 square into modulus of determinant of a2 b2 a3 b3. Like that you can write the remaining two. So based on this one we have one question, that is level 1 classwork 26th question. The triangle here, question is the triangle formed by the lines root 3x plus y minus 2 is equal to 0, root 3x minus y plus 1 is equal to 0, y is equal to 0. These are the three lines. Y is equal to 0 is nothing but x-axis. Is what it is a equilateral triangle, is a right angle triangle, right angle isosceles triangle, or isosceles triangle. For suppose the triangle formed by these three lines, so here we can go in two methods. So I am explaining one method, remaining methods you can do. You can find the angles between two lines, first line and second line, and angle between these two lines and angle between these two lines. If you get all angles equal to 60 degrees, that is an equilateral triangle. If any one of the angle is only 90 degrees and remaining are different angles, then right angle triangle. And if one angle is 90 degrees and other two angles are 45 degrees, then right angle isosceles triangle. And if two angles are equal and third one is different, then isosceles triangle we have to use. So based on equal, that is angles, angle between two lines, if you use this concept, we can say directly answer, but that will be little bit lengthy. So if they given like this question, so if you use this concept also, by using this concept also we can find the answer. Okay, here so first equation root 3x plus y minus 2 is equal to 0, that is so this is I am using this method, I am not using angles. a1 is equal to root 3 and b1 is equal to 1, a2 is equal to root 3, b1 is equal to minus 1. Here x is not there, so a3 is equal to 0. Here y coefficient is 1, so b3 is equal to 1. So apply in this formula. So root over a1 square plus b1 square into modulus of determinant of a2 b2 a3 b3. So write this formula and substitute here. So a1 square is nothing but root 3 whole square, that is 3, plus b1 square is 1 into modulus of determinant of root 3 minus 1 0 1 is to root over a2 square plus b2 square means root 3 whole square 3 square plus minus 1 whole square is 1 only into modulus of determinant of a3 b3 is 0 1, a1 b1 is root 3 1 is to root over a3 square plus b3 square, that is 0 square plus 1 square is 1 into modulus of determinant of a1 b1 and a2 b2, that is root 3 1 a3 root 3 minus 1, substitute here. So this is equal to root 3 plus 1 is root 4 into modulus of determinant, just expand, then don't, after expansion don't write this symbol, so only outside symbol you have to write. So determinant expansion is just cross multiplication, root 3 into 1 root 3 minus 0 into minus 1, that is 0 only, so root 3 minus 0 is 2, same root 4 into modulus of determinant expansion 0 minus root 3 is to 0, root over 0 plus 1 is 1 only, modulus of this is root 3 into minus 1 minus root 3 minus root 3 into 1 minus root 3. If you expand, this is root 4 is 2 only, root 3 minus 0, that is root 3. So modulus is positive only, just write root 3 is 2, root 4 is 2 and modulus of minus root 3, that is plus root 3 only. So totally plus 2, root 3 is 2, this is minus root 3 minus root 3 minus 2 root 3. So minus 2 root 3 modulus is there, so we have to write plus 2 root 3. So all 2 root 3, 2 root 3, root 3 get cancelled, then we have 1 is to 1 is to 1. If the sides are in the ratio, same ratio, that is 1 is to 1 is to 1, then it is called the equilateral triangle. If we get 1 is to 1 is to 1 equilateral triangle, if we get 1 is to 1 is to root 2, that is right angled isosceles triangle. So this concept we have in either 9th class or 8th class. Okay. Next one. So based on areas of the triangle, already I gave these formulas, but a little bit depthly you can discuss. So first one is area of the triangle formed by ax plus by plus c is equal to 0 with coordinate axis is c square by 2 into mod ab. Already I gave this formula. That means that one will be like this. This is the coordinate axis. This is ax plus by plus c is equal to 0. So whenever it is ax plus by plus c is equal to 0, this is x-axis, this is y-axis, this is 0. Then here x-intercept is nothing but minus c by a. Y-intercept is nothing but minus c by b. So this is 90 degrees. So half into modulus of perpendicular distances. This is the right angle triangle. Half into modulus of minus c by a into minus c by b, that gives c square by 2 into mod ab. Okay, so area of the triangle formed by, if they given x by a plus y by b is equal to 1, here very clearly x intercept is a, y intercept is b, then it becomes to a, then it becomes to b. So same formula, half into modulus of a into b here. If they given in this form, you have to write c square by 2 into mod ab. If they given in this form, you have to write modulus of half into modulus of ab. Okay, so next one is area of the region bounded by a into mod x plus b into mod y plus c is equal to 0 is. So here the area of the region bounded by, very important, a into mod x plus b into mod y plus c is equal to 0. To avoid mod x, we have to write plus or minus x. To avoid mod y, you have to write plus or minus y. Whenever if you write plus or minus x plus or minus y, so then this one gives 4 equations. One is ax plus by plus c is equal to 0. Another one is, if you keep this is ax only, this is minus by you can use, plus c is equal to 0. Already I explained based on this concept in previous classes. So like that we can get 4 line equations. Okay, 4 line equations. One is ax plus by plus c is equal to 0. Another one is minus ax plus by plus c is equal to 0. Another one is minus ax minus by plus c is equal to 0. Ax minus by plus c is equal to 0. So then you get this is the region you may get based on this. A mod x plus b mod y plus c is equal to 0. Then this area is nothing but, see here, this is nothing but right angle triangles. It forms a rhombus. Okay, so actually it is nothing but we have considered in a coordinate axis. Okay, actually here this is all this formed by some ax plus by plus c is equal to 0 only. So this length and this length is equal, this length and this length also equal, so this rhombus also becomes to square only. Okay, area of this square is nothing but, see here, so here it is bounded by four right angle triangles having same lengths. Okay, having same lengths. So this is nothing but minus c by b, this is nothing but minus c by a. So this is equal to 4 times of area of one right angle triangle is nothing but c square by 2 into modulus of ab. I explained about this one in previous note. Okay, so that is equal to 4 times of c square by 2 into modulus of ab. So here 4 in this 2 in this 4 2 times going, so totally we have 2 into c square by modulus of ab. Okay, this is the answer for that question. Next one is area of the parallelogram formed by the lines a1x plus b1y plus c1 is equal to 0 and a1x plus b1y plus c2 is equal to 0. So these two are parallel lines because of except constants remaining are same. And a2x plus b2y plus d1 is equal to 0, a2x plus b2y plus d2 is equal to 0. These are also parallel lines except constants remaining parts are equal. So here so these four lines forms a parallelogram. Then this area becomes to c1 minus c2 into d1 minus d2 by a1 b2 minus a2 b1. So to prove this one, I give one formula. Actually, the area of the parallelogram, the area of the parallelogram whose distances, whose opposite side distances are p1 comma p2 and angle between any two adjacent sides is theta, then area of the parallelogram is equal to p1 p2 by sine theta. Already I gave this formula in coordinate system. In coordinate system only I gave this formula. Okay, if you don't know, just to remember the formula, just enough. In trigonometry again you may get this formula. Okay, actually the concept is nothing but, so this if it is a parallelogram and the distance between these two parallel lines is p1, it is not a perpendicular distance from vertex to opposite side. It is the distance between these two parallel lines is p1, and second, the distance between these two parallel lines is p2. Okay, is not given height of the parallelograms. Okay, distance between opposite sides p1 comma p2, then area is equal to p1 p2 by sine theta, where theta is the angle between any two adjacent sides. In coordinate system only we have. Based on this one I am proving this one. Okay, see, let us consider this is a1x plus b1y plus c1 is equal to 0, this is a1x plus b1y plus c2 is equal to 0, this is a2x plus b2y plus d1 is equal to 0, this is a2x plus b2y plus d2 is equal to 0. So actually the distance between these two parallel lines is nothing but c1 minus modulus of c1 minus c2 by root over a1 square plus b1 square, that is only p1, distance between two parallel lines. Or I consider if it is a p1, okay, you take this is a1x plus b1y plus c1 is equal to 0, it is a2x plus a1x plus b1y plus c2 is equal to 0. So let us consider if it is p1, so the distance p1 is nothing but c1 minus c2 by modulus of c1 minus c2 by root over a1 square plus b1 square, and p2 is nothing but distance between these two parallel lines, that is nothing but modulus of d1 minus d2 by root over a2 square plus b2 square by sine theta is nothing but, what is sine theta formula? Angle between these two lines. Angle between these two lines are nothing but, let us consider, one is a1x plus b1y plus c1 is equal to 0, another one is a2x plus b2y plus d1 is equal to 0. Let us consider these two are the lines. Then angle between these two lines is nothing but, what can you say? By using sine theta, by using sine theta I gave formula, that is nothing but a1 b2 minus a2 b1 by root over a1 square plus b1 square into a2 square plus b2 square. In previous class we discussed about angles by using sine theta, cos theta, tan theta. Okay, so use that one. So here So this root over a1 square plus b1 square, root over a1 square plus b1 square cancel, root over a2 square plus b2 square, root over a2 square plus b2 square also cancel. Then we have ultimately modulus of c1 minus c2 into modulus of d1 minus d2 by modulus of a1 b2 minus a2 b1. But you understand here, so modulus of some k1 into modulus of k2 is nothing but modulus of k1 into k2. So directly we can write only one modulus, that is modulus of c1 minus c2 into d1 minus d2 by modulus of a1 b2 minus a2 b1. In other words, also we can write only single modulus. Modulus of k1 by k2 also we can write modulus of k1 by k2 is nothing but modulus of k1 by modulus of k2. So this is nothing but modulus of k1, this is nothing but modulus of k2. So this one you can write as modulus of c1 minus c2 into d1 minus d2 by modulus of by a1 b2 minus a2 b1. Directly this one also we can write, or you can stop here, or you can expand to this form. Okay, so this is the one of the important theorem. Next one. Next one is area of the triangle formed by lines a1x plus b1y plus c1 is equal to 0, a2x plus b2y plus c2 is equal to 0, a3x plus b3y plus c3 is equal to 0 is delta square by 2 into modulus of lambda 1 into lambda 2 into lambda 3. So here we discuss with the delta, lambda 1, lambda 2, lambda 3. Okay, for suppose the area of the triangle formed by given three lines. First line is this one, second line is this one, third line is this one. Then what is this area? Is nothing but delta square by 2 into modulus of lambda 1, lambda 2, lambda 3. In general, we can find area of this triangle in 10th class method. Is first you have to find out the point of intersection of these two lines. That gives this is the point of intersection of these two lines, that is this point, the point of intersection of these two lines, that is this point. So in coordinate system I gave the area of the triangle using the coordinates x1 y1, x2 y2, x3 y3. So half into modulus of x1, x2, x3, x1, y1, y2, y3. Okay, I gave the formula by using coordinates. Okay, so that is little bit lengthy. Finding the vertices of the triangle is lengthy. After that we have to apply again formula, area of the triangle. So without doing that much lengthy method, if you use a determinant form, that is delta you take as 3 by 3 determinant, that is coefficients of first equation, second equation, third equations we have to write in the rows, that is a1 b1 c1, a2 b2 c2, a3 b3 c3. Expand this one, you get some value. So take that square of that value, delta square by 2 into here lambda 1 means except first equation use second equation coefficients of x, second and third equations coefficients of x and y, that is a2 b2, a3 b3, that is 2 by 2 determinant. This expansion is nothing but cross multiplication only. 3 by 3 determinant, you know how to expand. Okay, lambda 2 is nothing but leave that second equation and use the coefficients of x comma y of third the first equations, that is a3 b3, a1 b2, and expand this one, that gives lambda 2 value. 2 by 2 determinant, it is not modulus. Okay, lambda 3 means, so leave the third equation and take the coefficients of x comma y of first and second equations, and you have to write here modulus of, that is determinant of a1 b1, a2 b2. Expand this one, it also gives one more value, and substitute here, you get the area of the triangle. Very easy. So based on the what you covered today, so I explained some problems in next video.